A very awesome good afternoon to all of you present here. We hope you have enjoyed our previous sessions that was held on yesterday, that is on 1st of June. Two sessions were completed yesterday. In the first session, we discussed about the fumigation, and in the second session, we discussed about cleaning of the glasswares and their sterilization. Now, today we are beginning our session with preparation of the solution, volume by volume, by Dr. Suresh Kumar Jatwa, Assistant Professor, School of Biotechnology, RGPV Bhopal. Dr. Suresh Kumar Jatwa, kindly throw light on the preparation of solutions, that is volume by volume. Dr. Suresh Kumar Jatwa.
Thank you very much, ma'am. A very warm good afternoon to each and everyone. Shall we start, ma'am?
Sure, please start.
Okay.
You are audible also. Your presentation is visible also.
Okay. Thank you. Thank you very much, ma'am.
Start.
So, as we know, solutions are very important component of the lab when we are performing any type of experiment. So, the preparation of solution accurately will always enhance the chances of success of your experiment. So, today we will discuss about the solutions, that is stop and working. So today we will discuss about the solutions, measurement of chemicals, different chemical concentrations, dilution of stock solutions, labeling, lab safety. All these content will be covered during the entire session. So solution, what is a solution? Solution is nothing when a known amount of solute dissolved in known amount of solvent, the resulting component is known as solution. So what is solution? Solution is the substance which dissolves in a solution. The substance which you are going to dissolve in solvent is known as solute, and in which you are dissolving your solute is known as solvent. As a result, the homogeneous mixture will form. This is known as solution. Here you can see the solute, this one dissolved in water. Water is a solvent. So when mixing these two components, this aqueous or homogeneous solution will occur, will form, known as solution. Solutions may be of three types. As here you can see the increasing concentration from this side to this side. Here it is written as unsaturated solution. It means there may be chances for more solute dissolves. You can dissolve more solute in this. This is unsaturated solution. This type of solutions known as saturated solution. So what is saturated? The saturation is the point at which solution of a substance can dissolve no more. So this type of solution known as saturated solution. And this type of solution known as supersaturated. It means it becomes unstable or crystals form. So supersaturation is refers to a solution that contains more of the dissolved material than could be dissolved by the solvent under normal circumstances. These are some common units which we use always in our laboratory, like weight by weight. It means if you are preparing a percent solution, if you are preparing a percent, this is percent solution by weight. If you are preparing by weight percent solution, it means you are dissolving solute in grams for 100 grams of solution. The solution symbolically known as percentage W by W. W stands for weight. And in volume solutions, here the solute is in ml, means liquid. It is in liquid, dissolved in 100 ml of solution. Total solution is 100 ml. So your solvent and your solute both are in liquid. This type of solutions known as percent volume by volume. And weight by volume percent, you sometimes you dissolved the gram of solute for 100 ml of solution. So this type of solution known as percent weight by volume. Apart from this, these are three common terms: molarity, normality, and molality. So what is molarity? Molarity is nothing. It is a moles of solute dissolved per liter of solution, and it is denoted by capital M, where normality is number of equivalent weights of solution. Number of equivalent weights of solution dissolved per liter of solution. It is denoted by capital N, where molality is moles of solute grams dissolved per kg of solvent, and it is denoted by small m. Weight per unit volume like gram per liters, milligram per milliliter. Apart from this, one term is there also, that is ppm. Ppm is what? Ppm is parts per million. So the number of parts of solute per million parts of total solution. How you prepare a percent solution weight by weight, W by W. So this type of percent solution is usually expressed as W by W, as earlier I said, where W denotes for weight, usually in grams in both cases. When you are preparing a percent solution weight by weight, it means your solute and solvate in both, the usually the unit is in grams. Such solutions is rarely, if ever, prepared in the laboratory, since it is easier to measure volumes of liquid rather than weigh the liquid on an analytical balance. So for preparing weight by weight solution, the formula is concentration percent weight by weight is equals to mass of solute upon mass of solution multiplied by 100. Why we are multiplying by 100? Because it is percent solution, and percent is parts per 100. Parts per 100. That's why we are multiplying it by 100. Okay. We can see it with an example, like correct definition of this type of solution is 5 gram per 100 gram weight by weight. If you are taking this example, what does it mean? If a solution you have that denotes 5 gram per 100 gram weight by weight, what does it mean? Which indicate that 5 grams of solute for every 100 grams of total solution. If you are preparing weight by volume solution, sometimes it's also referred as mass by volume. Sometimes it's also known as mass by volume, or abbreviated as mass by volume or weight by volume. It describes the mass of the solute which you are going to dissolve in grams per 100 ml of resulting solution. So formula for this is percent weight by volume is equals to mass of solute in grams upon volume of the solution in ml multiplied by 100. Here you can see example preparation of 10% weight by volume NaCl solution. So how will you prepare 10% weight by volume? So 10% means first you have to calculate what is the 10% of total solution. How much you are preparing? If you are preparing 100 ml, so what is your percent means 100. So you prepare for 100. If you are preparing more solution, you prepare according to that volume. So the 10% NaCl solution has 10 grams of sodium chloride dissolved in 100 ml of total solution. It is very important thing. Why? But when you are preparing solutions weight by weight, sorry, volume by volume. So volume by volume, the percent solutions describe the volume of the solute in ml per 100 ml of resulting solution. So it could also be calculated with the formula. Volume by volume percent is equals to volume of the solute in ml upon volume of the solution in ml multiplied by 100. You can see an example, that is preparation of 30% volume by volume sulfuric acid. So how will you prepare 30% volume by volume? It is not weight by volume, it is not weight by weight, it is volume by volume. So If you are preparing 30% volume by volume, so it has 30 ml of sulfuric acid dissolved in 70 ml water. How? Man, as I earlier said, percent is the parts per 100. And here the problem is saying 30%, 30 parts. 30 parts of 100 becomes 30 ml. And when you are subtracting 30 ml from 100 total, it becomes 70 ml. So 30 ml is your solute dissolved in 70 ml of your solvent. It becomes total 100 ml. Then 100 ml resulting solution is your 30% volume by volume sulfuric acid. Here I have described in detail. First you calculate the required volume of the solute. So you are required 30% volume by volume. When you calculate it, it comes 30 ml. When you subtract 30 ml from 100, total percent 100, it comes 70 ml. So 70 ml is your solvent, 30 ml is your solute. When you dissolve this, mix it, it gets total volume 100 ml. Then this 100 ml final volume of solution has having 30% volume by volume. So measurements and significant digit, it plays very important role to prepare your solution accurately. If you are unable to read significant digits or unable to measure is significant or correct in the volume or in the flask on the glasswares, you will not able to prepare a solution accurately. So the significant digits in a measurement consist of all the digits known with certainty plus one final digit, which is uncertain or is estimated. For volumetric measurements, you need some apparatus like micropipettes, volumetric or transfer pipettes, Mohr pipettes, and serological pipettes. These will help you to take the accurate amount of liquid. To make solutions, you need some containers also, volumetric containers like beakers, flasks, diluted cylinders, measuring cylinders, or burette. So what is beaker? Beaker is not designed to accurately measure volume of liquid. You always remember. It is only designed to hold a particular amount of liquid. It comes in various sizes with different calibrations. So you never use beakers to measure any liquid. If you measure any liquid or any solvent or solid with the help of beaker, the measurement have a plus minus 5% error. It means it is approximately, it is not accurately. So please do not use beaker for measuring any chemical. About Elmer's flask, flask is also not designed to accurately measure volume of the liquids. It is useful stirring solutions during titration and synthetic work. It also comes in various sizes, most commonly 250 ml and 500 ml. It also designed to hold a particular amount of liquid. About graduated cylinders. So these are the glasswares which you use to measure your solvent or solute or a solution in accurate amount. So tolerances vary with the size of the graduated cylinders. More accurate and precise than flask and beaker for the function of measuring. It is calibrated to contain or to deliver a precise amount of liquid. So when you measure a known volume of any liquid or any solution in a container, the term comes used as meniscus. So what is meniscus? Meniscus is the curved, this one. Solutions filled up to this mark like this. Here you can see This is the meniscus. So meniscus is what? Meniscus is the curved surface at the top of the liquid label formed in container. It is known as meniscus. Here you can see like this, and here you can see like this, dome shaped, like this, upward, and this is downward. So why it is formed downward and why it is formed upward? So this is known as concave meniscus. So concave meniscus, which normally will occur when the molecules of the liquid are attracted to those of the container. Molecule of the liquid, what you are measuring in the container, these are more attracted with the surface of the container, glass. When such type of glassware are there, then you form the concave meniscus. This occurs with the water and the glass tube, is an example. And convex meniscus occurs when the molecule have stronger attraction to each other rather than the glass surface of the container. Then a meniscus formed is known as convex, like this, dome shaped. Example with mercury and glass. Measurement. So this is important step when you are measuring any volume or any solvent or solute or solution in a container. Measurement of the meniscus is very important. So water and aqueous solutions will form a concave meniscus when placed in a graduated cylinder. So like this, curved shape, like this is meniscus. So as the water molecule are more strongly attracted to water glass than each other. So this meniscus formed like this in curved shape. So reading of this meniscus accurately will confirm the accurate amount of volume present in the container. If you read this with your upward to direct upward like this, it shows a upper volume, upper side. If you read this from down to downward, it will show some reduction in the minimum amount. So the correct line of volume you have to see with your eye level in this direction. This direction. This will be your correct side of measurement. To read eye level and the volume measure is lead to proper number of significant digits like this. So how will you determine what is the volume present in particular container? Like this, you can see this is the meniscus. Here you can see filled in a container. Okay. So how will you measure? So first of all, determine the smallest division marked on the graduated cylinder. What it says? Smallest unit, smallest divisions. What is this? You can see this one like this to this, this to this, this to this. This is the smallest division. So you have identified this is the smallest division. First step is completed. Then find out adjacent marking that have numerical label. What is the subjacent adjacent marking? That is, here you can see this is 6 and this is 8. And your meniscus is between 8 and 6. It is here. So you have also identified these are the two digits 8 and 6. And this one is the smallest division. So subtract and divide by the number of divisions between the numeric label. So all these things can be clarified by this slide only. Okay, here you see the same picture is here. In step 1, you have identified the smallest division. It is this one. Okay, and marking on the container is adjacent marking on the container is 6 and 8. Okay, if you count the smallest division between these two adjacent marking, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there is 10 smallest or smaller divisions in between two adjacent marking in between 6 and 10. So there are 10 divisions. So when 8 minus 6, it becomes 2 divided by total number of smallest digit is 10. It becomes 0.2 ml. So it is the measurement of the smallest division. Means each smallest division is of 0.2 ml. Okay. Then second step, the first certain digit is 6 ml since the meniscus is below 8 ml. Here you can see the meniscus is here, it is below 8. Okay. So here is 6, it means 6 ml is there. Then what is this amount? Okay. So we have to calculate this volume. Okay. So we can count from here to here the small division, that is 1, 2 and 3. You can see here it is the meniscus label. So it says that there are 3 subdivisions, smallest divisions. Okay. So 3 into 0.2, because each division is of 0.2 ml, it becomes 0.6 ml. So up to here it is 6 ml, and from this to this, how much? It is 0.6. So you plus 6 plus 0.6, the volume is 6.6 ml. The meniscus lies 0.1 of the distance between the marking. 0.1 into 0.2 ml is equals to 0.2 ml. So you add this particular unit in this, it is your final volume, that is 6.62 ml. So like this, you can measure your volumes in measuring cylinders or containers. Molarity. So what is molarity? Molarity is number of moles of a solute that are dissolved per liter of total solution. It means 1 molar solution contains 1 mole of solute per liter of volume. For an example, a 1 molar solution of H2SO4 means sulfuric acid contains 98 gram of sulfuric acid. Means the 1 mole of H2SO4, this, because 1 molar solution contains 1 mole of your solute. So solute is H2SO4. So the H2SO4 1 mole contains 98 gram of sulfuric acid in 1 liter total solution. So here the mole, so always remember, mole is an expression of amount, the amount of solute dissolved per liter of solution. It is only amount of solute. The mole is the unit of amount of solute, whereas molarity is an expression of concentration that a particular solution have. So molarity is different, mole is different. Mole is only the expression of amount of solute dissolved per liter of solution, and molarity is an expression of particular concentration present in the solution. There are some other units like millimolar, like micromolar. These also useful. This in such type of solutions you prepare in millimolar, and sometimes you prepare in micromolar. Normal solution. Normality is defined as the gram equivalent weight of the solute per liter of the solution. So what is gram equivalent? If you are describing like normality, like it is the gram equivalent weight of the solute per liter of solution, it means you have to calculate the gram equivalent weight of your solute, what you are going to dissolve. If one normal solution is equals to 1 equivalent weight of solute dissolved per liter of solution. The concentration of acids and alkalis are usually expressed in this unit. So gram equivalent weight is molecular weight divided by the number of H plus or OH negative ions released from one molecule of acid or base respectively in the solution. So by this definition, we can say that the equivalent weight is equals to molecular weight divided by the replaceable H plus or OH negative ions is equals to gram equivalent weight of that particular solute. How will you calculate gram equivalent weight? Here we can understand with this example. If you want to calculate the gram equivalent weight of H2SO4. So H2SO4, here you can see, contains 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. Okay, it means The sulfuric acid contains 3 atoms: hydrogen, sulfur, and oxygen. Okay. So weight of the 2 hydrogen atom is 2 grams, 1 into 2. And weight of sulfur atom is 32 grams. Weight of 4 oxygen atom is, because one oxygen atom's molecular weight is 16. So here we have 4. So 16 multiplied by 4 becomes 64. So when you sum up all these digits, the resulting unit will be the molecular weight of your H2SO4. That is 98 grams. When you are adding 2 plus 32 plus 64, it is 98 grams. Each molecule of acid releases 2 high H plus ions in solution. It means this 98 is the molecular weight divided by replaceable number of replaceable H plus ions, that is 2. So it becomes 49 grams. It means the equivalent weight of sulfuric acid is 49 grams. So 1 liter of 1 normal sulfuric solution contains 98 gram of H2SO4. Molarity express the number of, as we discussed, molarity express the number of moles of solute in per liter of solution. Here different thing is molality. So molality expresses the number of moles of solute dissolved per kg of solvent. It is dependent on density of solvent. It is different from molarity, as the latter refers to volume of the solution, which is temperature dependent. Molar solutions are not usually used in biochemical experiments. Preparation of solutions through dilution. It is important topic. How will you prepare the dilutions from stock? Once you prepared stock in higher concentration, now you want to use it as in your experiments, you have to prepare working solution, means some dilution. So when you are diluting any solution, you add some solvent. When adding solvent, the volume of solution will increase and concentration of the solute will decrease. So what are need to know? There is a concentration of the solution. The amount of solute that dissolved in certain amount of solution is known as its concentration. What amount of solute it contains? Initial and diluted solutions. So in initial and diluted solution, the concentration and volume are related by the following equation. Okay, so what is initial? Initial is your stock solution, whereas diluted is working solution. Means the initial solution is stock what you have prepared earlier. It is more concentrated. Now you want to dilute this to form a working solution. It is known as diluted solution. Okay, so in percent concentration, C1V1 is equals to C2V2. C1 denotes concentration, V1 denotes volume. Volume of your initial. Initial means stock solution. Whereas C2 is the concentration of diluted one and V2 is the volume of diluted one. That is your working. For molarity, it is M1V1 is equals to M2V2. So how you prepare this solution? So first you decide the volume and molarity of the final solution. It means you have to decide in which volume, what molarity I want to prepare my working solution. First you decide it, you calculate it. Then step 2 is determine the molarity of starting. It means the molarity of your stock solution. Then if you want to make solution in molarity concentration, so calculate volume of starting solution like M1 V1 is equals to M2 V2, where V1, this V1 and V2, the units are same. If you are taking V1 in milliliter, you consider M2 in milliliter. If you are taking it as in liter, you consider V2 also in liter. So we can understand this with an example. It is a problem. So please try to understand, where prepare 100 ml of 1 molar hydrochloric acid from concentrated 12.1 molar HCl. You always remember, read problem twice or thrice to understand what is given and what has to be calculated. Okay, so prepare 100 ml of 1 molar hydrochloric acid. Means it says you prepare 100 ml. It is B2. Please mute your mic. Somebody's mic is unmuted. Please mute your mic. Prepare 100 ml. It means it says you prepare 100 ml. This is the volume which you are going to prepare. It means it is B2 and 1 molar hydrochloric. The concentration of this solution is 1 molar. It means it is M2 from concentrated 12.1 molar HCl. So it is your stock solution. The molarity of stock solution is 12.1 molar. So if we see, this is V2, this is M2, and this is M1. So if we put these digits in the equation, M1 V1 is equals to M2 V2. So M1 is here given 12.1. Okay, V1 it has to be calculated, and M2 is 1 molar. It is desired concentration you want to make, you want to prepare, and volume is 100 ml. This one is given. So you solve for B1, it comes 8.26 ml concentrated HCl. It means if you take 8.26 ml of concentrated, means 12.1 molar HCl, and dissolve it in total volume 100 ml solution, the molarity of that final solution will be 1 molar. So how will you prepare it? So you take out 8.26 ml. It has already been calculated earlier. You take 8.26 ml of 12.1 molar HCl from the stock with the help of pipette and transfer to the 100 ml of volumetric flask. Fill in the volumetric flask with distilled water until it nearly to calibration mark. If you are not confident to make a accurate volume or accurate measurement, so up to calibration, please you use dropper. With the help of dropper, you can exactly go for the calibration mark. Then close tightly with a stopper and invert several times or shake well to get homogeneous solution. It is a pictorial presentation by which you can understand this is your stock solution, means initial solution. It is of 12.1 molar. So before taking your desired volume, first you shake it well. Then you take desired volume, transfer it into volumetric flask. Then you add your solvent up to your desired volume. What volume you need carefully. Then tight it, shake it well to get homogeneous solution. It is your desired and final solution what you want to prepare. Now dilutions with percentage. What volume of a 2% mass by volume HCl solution can be prepared by diluting 25 ml of 14% HCl solution? So please read carefully first and prepare a table. What is given in the problem? So here you can see you have to prepare 2% mass by volume. Here given this is percentage. 2% mass by volume means it has to be prepared. So it is your what? C2. It is the concentration of your final solution, and you want to make it from 14% mass by volume HCl from here. Okay, of volume 25 ml. You are taking 25 ml from this solution. This is 14%, and you want to make 2% mass by volume. How much? V1. What is the value of V2? Okay, so V2 is has to be calculated. Solve dilution equation for unknown. and enter values. These values in the C1, V1 equal to C2, V2. Very easy. Nothing is difficult. So you solve it for V2, then it becomes V1, C1 is upon C2. It equals to, is given 25 into 14. This is divided by 2. It becomes 175 ml. If you add 175 ml distilled water and 25 ml of 14% mass by volume HCl solution, the final volume is 200 and it becomes like 2% mass by volume. So it is the learning check question. So please read it carefully. How would you prepare 1000 ml of 1 molar solution of trace buffer from 3 molar stock of trace buffer? Here also the same thing. What is given? Here it is given 3 molar stock. Okay. So you want to prepare, you have to prepare 1 molar from this. And how much? 100 ml. So it is the V2 given. कितना चाहिए 1 molar. It is also given. It is C2. C2 is 1 molar. V2 is 1000 ml. And you have to prepare it from 3 molar stock solution. So this is your C1. You have to calculate V1. So what will be the V1? So C1 is the concentration of your initial, that is 3 molar, and V1 you have to calculate, and you want to prepare 1 molar, that is process of 100 solution, that is C2, and how much you are preparing? 1000 ml. So it is V2. So when you put these digits in this equation, 3 into V1 is equals to 1 into 1000. So V1 is equals to 1 into 1000 by 3. So when you solve it, the coming digit will be the answer or solution for V1. Another question, that is, what is the percent mass by volume of a solution prepared by diluting 10 ml of 9% NaOH to 60 ml? Here is given 10 ml, okay, of 9%. Means 9% is your C1. It is given. It is initial solution. You want to prepare, you have to prepare from this solution to 60 ml. So what will be the percentage? If you are taking 9% of 10 ml, okay. So here C1 is equals to 9, V1 equals to 10, and C2 is equals to, C2 you have to calculate it, V2 is equals to 60 ml. It is given here. So C1 V1 is equals to C2 V2, and C2 when you calculate for it, it comes 1.5. It means if you add 10 ml of 9% NaOH to 60 ml, the concentration of 60 ml will be 1.5 molar. It is another question. What is the molarity of solution prepared by diluting 0.180 liters of 0.6 molar HNO3 to 0.540 liters? Please prepare a table by reading this carefully. That is, what is given? Given is molar 6, that is your M1. Okay. How much you are taking? 0.18 liters. That is your V1. Okay. And you are diluting it into 0.540 liters. So it is V2. But molarity of this particular 0.540 liter solution has to be calculated. That will be your M2. By putting these digits in M1 V1 is equals to M2 V2, the answer is your 0.2 molar. Please solve it. What is the final volume of 15 ml of a 1.8 molar QH diluted to give a 0.3 molar solution? Try to solve it. First, make a table. What is given? So here if you read the question, what is the final volume of 15 ml of a 18 molar KOH diluted to 3 molar solution? Try to calculate it or practice it. So given is M1 is 1.8 molar, it is given, and you are taking 15 ml. That is V1, and M2 is 0.3 molar. So what will be the volume? So volume you have to calculate. When putting all these digits in the equation, M1 V1 is equals to M2 V2. By this calculating, the V2 comes 90 ml. So the 90 ml is your answer. Learning check, one more question. If I take 0.2 liters of 8 molar solution, both things are known. You are taking 0.2 liter from where 8 molar solution and diluted it to full liter, means 1000 ml. What is the new molarity? Now you have to calculate M2. This is V1, this is V1, and this is your M1. It is 8 molar. Okay. So when we're putting this equation in this, so you have calculate for M2, it becomes 1.6 molar. One important thing about the sulfuric acid. So when you are mixing concentrated sulfuric acid and water, you must add acid to water in ice bath, because sulfuric acid reacts very vigorously with water in a highly exothermic reaction, because water is less dense than sulfuric acid. So if you pour water to acid, the reaction occurs on the top of the liquid. It will harm to your health and mouth, hand and your mouth. So if you add the acid to water, it sinks and any wild reaction have to get through the water. Once you have prepared your solution, once you are going to prepare a solution, please remember three things. That is, do not use chemicals from unlabeled containers like this, because these are mysterious solutions. You don't know what is in that. So do not use chemical from unlabeled containers. Do not place label on top of one another. Label chemicals clearly and permanently. So once you have prepared your solutions in your desired concentration or desired volume, develop a habit, good habit, while working in the laboratory. That is, you make it, you label it. Why? Because an unlabeled containers will become tomorrow's mystery. Tomorrow's mystery. So reduce this type of confusion. You always develop a good habit. That is, if you have make it, please you label it. What you have to label? Identity of the contents, concentration, your name, date of preparation, and hazard alert, if any, or if applicable. So thank you very much for your attention. Now the next session, the topic will be discussed solution preparation weight by volume by Dr. Mrityunjay Singh, Assistant Professor, School of Biotechnology, RGPB Bhopal. So Dr. Mrityunjay Singh, please.
Thank you, sir, for your kind words. Dear participants, a very good afternoon to all of you. Today we are discussing preparation of solutions, that is stock and working solutions. The weight by today I am discussing weight by volume aspects. Now, first question is how to make a solution. For making a solution, you just first weigh the solid by using balance, analytical balances. For weighing your solutions, you require weighing pan, or just called weighing board, or you can use butter paper or watch glass. This is depends upon which type of chemicals you are going to weigh. Like if you are weighing NaOH, you can use watch glass, because NaOH can react with butter paper. After weighing your chemicals, just transfer it in half fill volumetric flask with deionized or distilled waters, and transfer it in volumetric class. Then stir it and try to dissolve all your substances in that amount of water. If required, add some solvent to dissolutions of that your solute. After that dissolution of your all solutes, you just make up the volume of your desired, which you require for your experiments. So then first question is, for measuring the substance, you require weighing balance. This is the pictorial diagram of analytical balance. The modern analytical laboratory balance work on the principle of magnetic force restoration. In this system, the force exerted by the object, that here it's so 10 gram, being weight is lifted by an electromagnet. Its work, its principle based on magnetic force restorations, and this electromagnet work to determine their weight. The detector measure the current required to oppose the downward. When you kept this weight on the pan of your analytical balance, it's create pressure downward, then counter with that opposed downward motion of the weight is countered by detector measures and detect it in respective their values. Type of weighing scales are generally three types: string balance, beam balance, and electronic weighing scales. The type of laboratory balance are four types: the top pan balance, top loaded balance, analytical balance, which is mostly used in laboratories, micro balance, and ultra micro balance. These micro balance and ultra micro balance is weighing for minute quantity. Top loading balance is having capacity 200 gram, and its lowest value which you can measure by this type of balance is 1 mg or 0.001 gram. Analytical balance can having capacity of 320 gram, and it can use 0.1 milligram. Micro balances have capacities, micro and ultra both are having capacities 6 gram, and it can use, micro balance can use at 1 microgram, and ultra micro balance can use 0.1, means at 7th position of decimal 0.1 microgram it can use precisely. Term used in weighing accuracy, it is ability to balance, to display the value close to the actual value. Means if you are going to weigh 5 gram and you know the weight of that substance is 5 gram, the balance is must show the value 5 gram. If balance is shows exact value, then it's accurate. Calibration, it is a comparison between output and standard value. At regular interval, you are requiring to calibrate your balance by known weighing blocks to calibrate your weighing machine for better functioning. Capacity, the maximum amount of weight that can be weighed on the balance. Just like capacity of top pan balance is 200 gram. Now increment, it is the finest division of the instrument. Linearity, the ability of balance to display correct reading throughout the weighing range, means the range of weighing is for any balance. If we are taking top loading balance is 200 gram to 1 mg, it's means if you are going to weigh either 200 or 10 milligram or 1 gram, at all level the balance should show correct value, then it's called precision. Readability, the smallest division of the division at which the scale can be read number of decimal point. Like in balance, ultra micro balance, it's 7th position of decimal you can measure precisely. Tear Tear button is there in analytical balances, which use to display show the zero values for reading. Operating of a analytical balance, do's and don'ts. Balance should be placed on solid, stable, plane, flat surfaces. Check the balance is level using the level indicator. In this, you can see the level indicator is there, where a bubble is there. That bubble is must be in circle. Then only this type of balance is working properly. Now, a wide location in which the balance could be exposed to any of the following: airflow from air conditioner, fans, doors or windows, vibration from the surroundings or nearby equipment. Like if you kept it nearby a centrifuge, it can show some variations in your uh, quantity you are going to take. Direct sunlight or radiations. Analytical balances have a draft seal or weighing chamber to prevent the very small sample from being affected by air current. You can see the draft seal. Well, in this here, it's called draft seal. Analytical balances. Do not use aggressive cleaning agents, because clean with a mild soaps and polish with a dry cloth. If you are going to use aggressive cleaning agent, it can harm the pan and it may show the wrong readings. Operate your balance in an environment where the ambient temperature is maintained between 18 to 30 degrees with fluctuation of less than 1 degree centigrade per hour. The good operating condition for relative humidity is 50 to 85 degrees centigrade. The operating and analytical balance, how to operate: check that the balance is on and that the door is closed. Press the tear button and wait for 5 to 10 seconds for a symbol appear on display, or similar symbols like asterisk or some other symbols which can show the instruments on their display. Symbol to appear in upper left, yeah, right hand corner of the display, and the mass to read 00 values. Open the door and place a weigh board, that is weigh paper or other containers like watch glass, on the center of balance pan, ideally with wedges or similars. Close the door and wait for the digital readout to stabilize. If you do not wish to include container mass in your measurement, then press after kept your container on pan and kept your close of your door tear button to reset the mass to 0. Remove the container from the balance and the substance to weigh. Avoid adding substances on the balance pan, as this can result in contaminating the balance. Return container to balance and wait 5 to 10 seconds, may take up to 1 minute for mass reading to settle. If the mass reading is unstable, it may be due to static electric buildup or other issues. Now, second instrument you are using for your chemical preparations is pH meter. A pH meter is an electronic instrument used for measuring the pH, acidity or alkalinity of the liquid. A typical pH meter consists of a special measuring probe, that is either glass electrode and a reference electrode connected to the electronic meter that measure and display the pH reading. pH is defined as negative logarithm of hydrogen ion concentration. That this equation shows negative logarithm of hydrogen ion, where P of pH is power and H for hydrogen, and in bracket H plus shows hydrogen ion concentration. This is a picture of pH meter. This is a pH scale. It's 0 to 14. These are example which contains the pH value, like gastric juice contains 1, pH value 1. For every number decrease or increase, we have to multiply by 10. Like pH 5 is 10 times 10 times weak acid than pH 4 substances. Likewise, pH 10 is 10 times more basic than pH 9 substances. The types of pH meters, normally 3 types: handheld pH meters, benchtop pH meters we are using in laboratories, and continuous inline pH meters. It is important parameter to determine the quality of water. pH scale is usually represented as from 0 to 14. Solutions with pH less than 7 are acidic, and solution with pH greater than 7 are basic solutions. pH is a temperature dependent. If pH is higher than desired, adjust it using a hydrochloric acid solutions. If pH is lower than desired, adjust it using sodium hydroxide solutions. The working principle behind the pH meter is the potential of glass electrode is measured against that reference electrode. The pH meter contains generally 2 electrodes. Sometimes it's combined and only 1 electrode is there. Here, 2 electrodes, reference electrode and glass electrodes. If you are measuring acidic solutions, hydrogen ions are going to interact with pH glass electrode bubbles. These are measuring a sensing element. And if you are using alkaline solutions, the hydrogen ion is coming from the bubble, because internally bubble contains a buffer solutions which interact with your chemicals and try to neutralize it. Calibration should be performed with at least 2 standard buffer solutions that span the range of pH values to be measured. Normally, it's pH 4 and pH 10 is using, because as we already discussed, below 7 is acidic, and more than 7 to 14 is basic solutions. So what a buffer up you are using, one is pH 4 which is in acidic range, and other is using pH 10 which is in basic range. The pH meter has one control to set the meter reading equal to the value of the first standard buffer, and second control which is used to adjust the meter reading to the value of second buffer. A third control allows for temperature to set. Buffer solutions. What is buffer solutions? Buffers are typically mixture of weak acid and its conjugate base, and its salt, or a weak base and its salt. The combination is called a conjugate acid-base pair, and it will resist the changes in pH upon addition of a small amount of acid or base. For making pH 4 buffer, dissolve 5.1 gram of potassium hydrogen penthalate in 250 ml of deionized water. Add 0.5 ml of 0.1 molar hydrochloric acid, then dilute it to 500 ml. For pH 7, which is generally used to keep your glass electrodes, normally Prepare 0.1 molar potassium phosphate monobasic solutions by dissolving 3.4 gram in 250 ml deionized water. Prepare 0.2 molar sodium hydroxide solutions by dissolving zero point 0.8 gram in 100 ml DI water. Mix 250 ml of the 0.1 molar potassium phosphate solutions and 73 ml of 0.2 molar sodium hydroxide solutions, and then measure, compensate the volume to 500 ml with DI water. Prepare for pH 10, prepare 0.025 molar sodium borate solutions by dissolving 2.38 gram in 250 ml of DI waters. Prepare 0.2 molar sodium hydroxide solutions by dissolving 0.8 gram in 100 ml DI waters. Mix 250 ml of 0.2 molar sodium borate solutions and 27 ml of 0.2 molar sodium hydroxide solutions, then dilute it to 500 ml. Another question is distill or deionized water. What do you or I need in our experiments in laboratory? Distilled water is free of inorganic materials, suspended impurities, and most organic contaminants. Deionized water, like distilled water, is free of organic material and most suspended contaminants. For laboratory applications, use, we require distilled water, but we can use deionized water, that is demineralized water can be used, because distilled water is costly in comparison with deionized water, and distilled water you can take only from laboratories or other places, but deionized water is generally you can take from market. If you need organic free water, use distilled water, because deionized water is containing some amount of organic impurities. How to increase the rate of dissolving solids? When you are going to dissolve your substances in solvent, a solvent will only dissolve a limited quantity of solute at a definite temperature. However, the rate at which the solute dissolves can be accelerated by the following methods. First one is pulverize or grind up the solid to increase the surface area of the solid in contact with the liquid. Means you just crush your substances and make it a small a minute particles and increase its surface area, which interact with your solvent, and the rate of dissolution solid is increased. Heat of the solvent, second one is heat the solvent. This will increase the rate of solutions, because molecules of both the solvent and solute move faster to interact and dissolve. Third one is stir vigorously. Combination of all these three methods when practiced will dissolve solid more quickly. Now preparing sulfuric acid solution, which already discussed by Suresh sir. Preparing sodium hydroxide solutions, a great amount of heat is liberated when sulfuric acid is added to water. The temperature may rise so fast that the solution will boil and possibly spatter a hot caustic solution. Add NaOH slowly with continuous stirring. Pay special attention to condition of the beaker or flask you use to prepare the solutions. If you use a glass vessel, it must be borosilicate glass free of any scratches or breaks. It can harm persons who are doing experiments. Preparing an iodine solutions. We prepare iodine solutions. Iodine crystals are not directly soluble in water, for which you are using potassium iodide solutions, which is why most water-based iodine solutions calls for potassium iodide as an ingredient. Iodine is soluble in potassium iodide solutions. As a general rule, start with approximately 1/4 of final volume of water and add the required amount of potassium iodide. Once the potassium iodide has dissolved, add the iodine crystals, stir until completely dissolved and bring the solution up to its final volume. Generally, the more concentrated the potassium iodide solutions, the more readily iodine crystal will dissolve. Iodine solutions should be prepared in fume. Unit conversion. For mass, 1 gram is equivalent to 1000 mc, or that is 10 to power 3 mg, and it equal to 10 to power 6 microgram, या 10 lakh microgram. 1 microgram is equivalent to vice versa 0.001 mg or 10 to power minus 3 mg, and it is equal to 10 to power minus 6 gram. Likewise, for volume, 1 liter is equal to 1000 ml and 10 lakh microliters. Like 1 microliter is equal to 0.001 ml and 10 to power minus 6 liters. Likewise, moles, 1 mole is equal to 1000 millimole and 10 to power 6 micromole. And 1 micromole is equal to 0.001 millimole and 10 to power minus 6 mole. Parts per million. It is used to express the concentration of solute present in trace quantity in solutions. Parts per million of components. We use this equation, parts of component upon total parts of all component in solutions multiplied by 10 to power 6. For solute, ppm is mass of solute is divided by total mass of solutions into 10 to power 6. It can be used in all type of solutions in which components are either solid, liquid or gases. If the solution is made up of liquid or gases, then ppm refers to the volume of liquid or gases, then masses of solid. So in place of masses of solid, you use volume of solute and volume of solutions into 10 to power 6. Now we understand this by solving this equations. If 1.25 gram of calcium nitrate is dissolved in 140 gram of H2O, calculate the resulting solution in parts per million. For calculation, solute is given, which is calcium nitrate. Mass of solute is given, which is 1.25 gram. Mass of solutions is equal to mass of solute plus mass of solvent. Mass of solute is 1.25 gram and mass of solvent which is H2O is 140 gram. Adding this, you get the mass of solution, which is 141.25 gram. To calculate ppm of solute, you use this equation, mass of solute upon total mass of solutions multiplied by 10 to power 6. Mass of solute is 1.25 gram and mass of the total mass of solution is 141.25 gram. Multiply by 10 to power 6, you get this value, and you can change or show your values as 8.85 into 10 to power 6. Percent solutions that already discussed. Avogadro number is number of atoms or molecules in 1 mole of substances. That means 1 mole of substances contains 6.022 into 10 to power 23 molecules or elements. Two problems are given here on Avogadro's number. For moles of substances, you just multiply Avogadro number to calculate number of atoms or molecules, and if number of atoms or molecules given, just divided by Avogadro number, you can get your moles of the substances. Problem 1 is 0.45 moles of Fe iron contains how many atoms? For 1 mole contains 6.022 into 10 to power 23. Likewise, here respectively, you calculate 0.45 mole, just multiply Avogadro number, you get it 2.71 into 10 to power 23. Problem second is 0.2 mole of H2O contains how many molecules? Just multiply 0.2 mole into Avogadro number and you will get the result, that is 1.2 into 10 to power 23. It's for H2O molecules. If you calculate for hydrogen molecules, just because H2O contains 2 hydrogen molecules, just multiply by 2, you get the number of hydrogen molecules in 0.2 mole. Percent weight by volume concentration calculation. It is expressed as the number of gram of solute dissolved in 100 ml of solutions. It is denoted by percent weight by volume, weight of solute in gram, volume of solutions in ml, multiply by 100 because you are taking percent. It is used to express the concentration of solutions when solid solute dissolve in liquid solvent. We understand better by using this examples how to prepare 0.9% weight by volume NaCl solutions, that is saline solutions. For this 0.9% weight by volume is given, and for NaCl weight of solute upon volume of solutions in multiply by 100. Weight of solute is given 0.9 and volume of solutions, its percent solutions, it's that's why you are using 100 ml. After calculation, you just get the 0.9 gram of NaCl in 100 ml of distilled water to get the concentration of 0.9% weight by volume. Example 2. How many grams of NaCl required to prepare 2.5 liter solutions of concentration 5% weight by volume? Concentration of NaOH solutions given 5% weight by volume. Quantity of NaOH solutions to prepare is given 2.5 liter, that is equivalent to 2500 ml. Weight of NaOH, that is solute required, suppose it is X. Just kept these values in formula. Concentration of NaOH 5% weight by volume. Weight of NaOH in gram. Volume of solutions in ml, multiply by 100. You suppose weight of solute is X gram. Volume of solution is 2500 ml into 100. Then from here you calculate X, which is 125 gram. Means 125 gram NaOH is required to prepare 2.5 liter solutions of concentration 5% weight by volume. Thank you all. I invite Dr. Suresh Kumar Jatwa for concluding remark of this sessions.
Thank you very much, Dr. Mrityunjay, for informative session. Okay, so in the today's entire session, we have discussed various things about the preparation of solution, because solutions are very important component while you are performing an experiment in the laboratory. So as we discussed, solution is what? The two or more substances are mixed together in known quantity, which you called solution. So for preparing these solutions, you may involve being of a precise amount of dry material, or maybe measuring a precise amount of liquid. So this step, I think from the entire session, we have learned in this particular preparation method, this particular step of measuring or weighing a dry material or a precise amount of liquid plays a very important role to make your solution accurately. Therefore, it always very important thing, preparing solution accurately will always improve an experiment safety and the chances for success of your experiment. So in the entire session, we have discussed, I think, about solution preparation, about the solute, what is solute, solvent, and solution, and their percent solution, percent by weight by volume, weight by weight, volume by volume, their concentration, molarity, normality, and pH. So many things we have discussed. So now I think so many information gathered by this entire session. So by concluding this session, I would like to say something about the lab safety. Apart from this, do not eat, drink, or smoke in the laboratory. Please always remember, do not eat anything in the laboratory, do not drink or smoke in the laboratory. Important thing related with your health, that is, do not prepare it by mouth, and never add butter to concentrated sulfuric acid. Never return any unused chemicals to their original container. This is very important thing. A silly mistake we done sometimes. Always keep your working area clean and tidy. Open bottles near window where ventilation is available. Handle concentrated acid and liquid ammonia with care. Label containers and solutions properly. Secure the tops of reagent bottles immediately after use. While working in the laboratory, wear a lab coat and appropriate eye protection. Wash hands after using any substance hazardous to the health on leaving the laboratory. One thing is very important, that is about the broken glasswares or sharps like needles. So keep broken glasswares and sharp material separate from other waste and dispose of in the appropriate containers. This is very important thing. So for the quality, to ensure the quality of the solution, you must know the solutions and their different concentration to represent them. Their documentation, labeling, recording of your experiment, what you have done in your laboratory. Traceability and availability of your solution. SOPs means standard operating procedures, and SPs standard procedures. And maintenance and calibration of your instruments regularly on time during the time intervals. Stability and expiration of date record. Proper storage for future. Thank you very much. Now I would like to call Professor Dr. Asna Tiwari, Dean Faculty of Applied Sciences, Rajiv Gandhi Padki Vishwavidyalaya Bhopal, and Director School of Biotechnology for the next session. So, Dr. Asna Tiwari, ma'am, please.
Thank you so much, Suresh. Kindly stop sharing of your slides. In this manner, we have completed our third session of the day, that is preparation of solutions, along with that weight by volume, volume by volume for the stock solution, or for the working concentration. Now, I request Dr. Mrityunjay Singh to please share the link of feedback session. Now, 2 sessions has already been over. I'm requesting the participants, if anybody wants to ask anything from our speakers, kindly put up your questions for the discussion. Participants, please. Dear participants, do you hear me? If you have any queries related with these 2 sessions, kindly put up your queries.
मैम मेरा क्वेश्चन है कि जब हम एनालिटिकल ये वेइंग बैलेंस यूज करते हैं, इज दिस टीयर इक्वल टू 0 क्या हम इस टेयर को 0 करते हैं क्योंकि हमारा जो एटमॉस्फेरिक प्रेशर वो 0 करते हैं हम, या फिर जो पेपर का वेट होता है जिसमें हम अपना सॉल्यूशन और जिसमें हम वह करते हैं उसको हम टीयर करते हैं और इक्वल टू 0 करते हैं।
Okay.
Dr. Mrityunjay, over to Dr. Suresh, anybody.
Shall I answer? Shall I answer?
Sure,
Okay.
please.
आपने क्वेश्चन किया है, जहां तक मैं समझ पा रहा हूँ, कि जब हम कोई भी मटेरियल को वे करते हैं इन एनालिटिकल बैलेंस, प्लीज म्यूट योर माइक, देयर आर सम डिस्टर्बेंस, प्लीज.
Kindly mute your mic, please. Kindly mute your mics, please. Thank you.
ओके, नाउ इट इज आई थिंक क्लियर. ओके, जहां तक मैं समझ पा रहा हूँ आपका प्रश्न ये है कि जब हम किसी मटेरियल को या किसी भी पाउडर्ड फॉर्म को वे करते हैं तो एनालिटिकल बैलेंस में हमें टेयर कब करना चाहिए टू गेट 0 है. तो जब भी आप वेइंग करने जा रहे हैं तो जो भी आप ले रहे हैं, पेपर ले रहे हैं, जो भी आप चीज ले रहे हैं जिसमें आपको वे करना है, उसको मशीन के उस पर रखकर फिर आपको टेयर करना है. क्योंकि अगर आप पेपर के वेट को टेयर नहीं करेंगे एंड यू आर टेकिंग इन माइक्रोग्राम्स और मिलीग्राम्स, इट विल इंटरफेयर विथ योर एक्यूरेट क्वांटिटी व्हाट यू वांट टू मेजर. तो जब भी आपको करना है तब आपको जिस भी पेपर में, जिस भी उसमें आपको वे करना है, उसके साथ आप मशीन को टेयर करेंगे. जब वो 0 आएगा देन यू कैन वे. थैंक यू.
Anybody wants to ask anything?
Ma'am, there are few questions in the chat box.
Please
If
tell.
Dr. Suresh and Dr. Mrityunjay can find them on the chat box, then please answer.
Madam Riddhi, is it possible for you to read that questions one by one?
Yes, ma'am.
Kindly.
Yeah. Just give me a moment, ma'am.
There is one question.
Yeah.
There is a question from Rashida Khan. Yes.
Yeah.
Her question is,
Yeah.
I have a doubt in meniscus topic. Am I right? First we have
Yes.
find the value 0.2, that is the smallest digit, है ना, in the cylinder, and at final we add 6.6 0.6. then what is the use of that? I cannot understand that. जिसने ये क्वेश्चन किया है उनका क्वेश्चन ये है कि इसमें हमने जो डिजिट लिया है वो 0.2 क्यों लिया है, ये कहाँ से आया है, या हमने कैलकुलेट कर लिया है टोटल वॉल्यूम कितना है, कुछ डाउट है इनको. सो हियर यू कैन सी द मेनिस्कस in the curved manner. This is the meniscus. So always you read the bottom of your curve. This is meniscus, bottom of your meniscus. It comes around this point on your scale. So when you count from here, there are 1, 2, 3, and 4. These are the smallest divisions. But when you are counting about 4, so it is above the meniscus. It is not the lower point of your meniscus contained in the cylinder. So this is the third point, is your right point for your reading. So this is up to 6 ml, and 1, 2, 3. These are the smaller divisions on the scale, and each division is of 0.2 ml. So when you calculate this, it becomes 0.6 ml. So up to this mark, this is the value of up to this is 246.6. So you add this value into 6. So 6, it becomes 6.6 ml.
Ma'am, somebody asking about hygroscopic substances. You must use watch glass for that substances, or weighing pan, weighing boat that is made up of plastic substances. You don't use butter paper; it can react, and you are not getting your exact amount, because some amount is stick on that paper or react with that paper. Thank you.
Dr. Suresh, kindly go through
Yes,
the
yes,
first.
ma'am. Questions once. Please mute your speakers. Please mute your mics. Please. Yes. अगेन मैम क्वेश्चन आया है कि हमने 0.6 क्यों ऐड किया.
Exactly.
Yes, ma'am. Okay, so I
Yes.
think there are some confusion. I am ma'am presenting once again my slide.
Sure.
So your question is why we added 6, no? So it is for calculation only, to understand how we measure the significant digits. It is only this. So when you see from downwards, it is 6, okay, it is 7, and it is 8. So between 8 and 6, there are 10 smallest divisions, and each division is of 0.2 ml. Okay, so it is already 6 ml here. Up to this, it is 6 ml already. The volume of your liquid container is 6 ml up to here, but your meniscus is here. You can see here. So it is above the 6. No, it is above the 6. That's why we have added 6. So it is 6 up to here, and 0.2, 0.4, and 0.6. Up to here it is 0.6. So it is from 1, 2, 3, 4, 5, and then there comes 6. So it is 6 ml. So 6 plus 0.6 is equal to 6.6 ml.
Somebody is also asking, Dr. Suresh, why always the lower meniscus?
Yes?
Somebody is also asking, some
Yes.
participant is also asking, why always the lower meniscus?
Okay.
For
Yeah,
the colorless solution and for the colored solution, upper lower meniscus. Why?
because the molecules in the solution sometimes attracts with the glass, this glass surface. So like water, if you are preparing some solution in the water, so water molecule attracts strongly with the glassware like this. So your meniscus comes in curved shape like this downward. In same manner, if you are having solution in mercury and glass, it will comes in domed shape, because in mercury there are molecules, the molecules present, they have stronger winding with each other apart from the glass. That's why.
I think you have satisfied with the answer given by Dr. Suresh and Dr. Mrityunjay. Anybody wants to ask anything? Somebody is asking which weighing board. Dr. Mrityunjay, just go to the chat box.
Weighing board is made up of plastic substances which you take from market. You can measure hygroscopic substances in that board. Otherwise, you can use watch glass, which is made up of borosilicate,
Chances
for
of
weighing your hygroscopic substances. Earlier, I already said about NaOH, which is also taking moisture from environment. You use watch glass.
anybody else wants to ask? The question is also there in the chat box. Kindly go through that.
Any other substances constant the pH value.
Huh.
No, for stabilizing, you can use a stabilizer for chemical reaction, for chemical solutions, and for adjusting pH. For basic, for acids, you use NaOH, and for basics, you use HCl solutions. For stabilizing your substances, you can use buffer also. Buffer is just prevent the changes in your pH rate.
Go to the chat box. There is one question related with you also.
So as I already discussed, when you are taking water as a solvent in the solution, so the molecule of water have some attraction between with the glass or container surface. That's why the meniscus formed in curved shape. Water molecules present in the solution have some attraction with the surface of the glass. That's why a meniscus formed.
on the basis of the nature of the molecules which are present in the solution, whether they are colorless or colored. That's why they are forming the meniscus in the concave shape or in the convex shape. Sure. Over to Dr. Mrityunjay, please.
I'm already replied that. For hygroscopic substances, you must use watch glass. If you are going for minute quantities, you can use even the tube and close the cap so that it not react with air. But if you are going to weigh large quantity, you must go on open system like watch glass.
I think our dear participants have satisfied with the answers given by our resource persons or panelists, whatever they have their query. We are very grateful to you all. You have shown your interest, very warm interest towards our first workshop, and continuously you are asking for the remaining workshops or the coming workshops also. Now we are proceeding towards the feedback session. I request Dr. Mrityunjay kindly coordinate the feedback session. In the meanwhile, I'm just giving the glimpses of the department, that is School of Biotechnology, which is going to present such workshop. Which type of department we have, which type of facilities we have, just in a very short span of time. The manner in which when you are filling up your forms, we are just sharing that to you. We are just giving the glimpses of the School of Biotechnology, who is presenting a series of 5 workshops under the Consortium Biotech Workshop. This School of Biotechnology was established in the year 2003, and the course MTech Biotechnology was approved by AICT New Delhi in the year 2004. Second course the School of Biotechnology is running, that is PGCMB course, postgraduate certificate program in medical biotechnology, that was started in the year 2017 under the umbrella of RGPV Bhopal, with the vision to prepare ourselves for the new knowledge age so as to shape the Indian horizon in respect of science and technology capabilities in one of the core sectors of economy, to create the much desired change waves to accelerate India's advancement towards economy and superpower. Now, with the mission of the School of Biotechnology is to build up state-of-the-art infrastructure facilities for world-class research and development and balanced innovative teaching programs commensurate with the need of the nation, and particularly in Madhya Pradesh or the state. Hence, the motto set by the School of Biotechnology are to expose the students to recent exciting developments in the area of biotechnology and their exploitation in industry, agriculture, and medicine, with the main emphasis is on genomics, proteomics, and bioinformatics, so that we provide education and research in biotechnology directly towards distinct economic, health, and social objectives. Hence, the School of Biotechnology is mainly focusing on the important objectives, which are as follows. Number one, develop or produce trained manpower with strong knowledge base in various disciplines of biotechnology. The second objective of the School of Biotechnology is prepare students to discover their latent potential and work as efficient and disciplined biotechnologists. Third is stimulate their creative thinking to do innovative work in diverse branches of biotechnology at their potential, which is required, or that is the need of an hour for the society also. The School of Biotechnology is running 4 courses. Number one, MTech Biotechnology 2-year, 4-semester course. Number two, PGCMB, as I discussed earlier, postgraduate certificate program in medical biotechnology, 2 semesters, 1-year course, PhD, that is doctoral course, and postdoctoral course also. Doctoral course and postdoctoral course are as per the directives of UGC, AICT, and RGPV itself. MTech Biotechnology is running as per the directives of AICT. The number of intake for MTech Biotechnology course is 80, and PhD, that is 6 as the main students and 5 as the that is co-supervisor and supervisor, 6 as the main supervisor and 5 as the co-supervisor of the doctoral fellows or the PhD students. In PGCMB, we have the intake of 10 students per year, 2 semesters, 1-year course. And the mode of selection, that is for the MTech Biotechnology, on the basis of the gate percentile. If the seats are not filled on the basis of gate percentile, then on the basis of the merit of the eligibility course for the non-gate students. What is the eligibility of this course? These are the eligibility for MTech Biotechnology course, either BTech Biotechnology or food technology or biomedical engineering, chemical engineering, bioinformatics, B Farm, or MSc in any of the disciplines of biochemistry, microbiology, veterinary sciences, agricultural sciences, all branches of life sciences, bioinformatics. These are the eligibilities of MTech Biotechnology. And now we have the eligibility for postgraduate certificate program in medical biotechnology. That is the same eligibility which we have discussed for the MTech Biotechnology. That is BTech Biotechnology, food technology, biomedical engineering, chemical engineering, bioinformatics, B Pharma, BSc or MSc. That is different from MTech Biotechnology. Undergraduation in any of the branches of life sciences, biological sciences, or MSc in any of the disciplines of biochemistry, say BSc or MSc in microbiology, veterinary sciences, agricultural sciences, life sciences, bioinformatics. These are the eligibility to take admission in either MTech Biotechnology 4-semester, 2-year course, or PGCMB, postgraduate certificate program in medical biotechnology, 2 semesters, 1-year course. Fee structure is that is very nominal, 25,000 tuition fee per semester, along with the other developmental fees, caution money, enrollment fees. That is the total fees for the first semester is 36,950 for the MTech Biotechnology, and the same structure is applicable for PGCMB. But second semester, the fees is reduced because you have already paid the remaining fees in the first semester or in one time in a course of 2 years, 4-semester course. Only tuition fees and examination fees you have to pay for the subsequent semesters. Likewise, the second semester, third semester, and fourth semester. The total fees for the completion of 2 years, 4-semester MTech Biotechnology courses, 1,21,750. While in the case of PGCMB, the fee structure is similar to the MTech Biotechnology up to the first and second semester. That is 63,250 is the total fees of 2 semesters, 1-year course of PGCMB, along with for the both the courses, if you are interested to stay in the hostels, along with the hostel fee. That is for the first semester, 6,400 rupees is the hostel fees for the room rent, out of which 4,000 is the caution money. Only 2,400 rupees is the room rent of 6 months first semester and subsequent semesters, second, third, and fourth, along with the mess fees. Now, curricular aspects, as we know very well, this is the semester system. We have the 4 semesters. First year, first and second semester, second year, third and fourth semester. First and the second semester, in the first year, we have 5 papers, along with the 2 practicals. And the third semester, we have third and fourth semester, that is completely 1-year dissertation work. I'm just repeating, third and fourth semester, that is second year, 1 whole year is mainly focusing on the research work so that the students can publish their output of their research, that is in the form of research paper, or they can publish one review article on which they are going to start their work or designing their project. So one review article and one research paper in the refereed journals, that is compulsory at the time of submission of thesis. That's why the School of Biotechnology is have 1 year, 2 semesters dissertation work, so that some positive, some concurrent outcome will become after the completion of 1 year dissertation work. We have designed the curriculum on the basis of need of an hour and demand of the course. Number one, because you know very well, we are living in the era of biotechnology and bioinformatics. Training, we are providing the training to fulfill the gap between the academia and industry. The curriculum of biotechnology is based on the curriculum of Consortia of India Limited, that is BCIL New Delhi curriculum. And this curriculum is framed by the experts of IITs and industries. Two experts from the IITs and two experts from the industries. Then the main focus of this curriculum is on the students' attributes and on holistic development of that institutes, that students that can display multiple skills and qualities. Whatever are the qualities the students will have, they have to show their qualities in this platform of School of Biotechnology at the level of PGCMB or at the level of MTech Biotechnology. Student will achieve core competencies and to face the global requirements successfully. We are just training our students in such a manner that they can compete with any of the students, not only at the state level or national level or international, but they can face the challenges up to the global level, that is at the international level. Dear participants, I'm very happy, I'm very glad to inform you that the students, the alumni of School of Biotechnology, RGP Bhopal, is representing many of the key positions globally also. Some our alumni are entrepreneurs also in the field of biotechnology and allied fields. Hence, day by day advancing the research facilities as per the emerging new technologies, and student will succeed through skill development in the job market to commensurate with social, cultural, economic, excuse me, and developmental realities at the local, national, and international level. Hence, the core faculties which are present in the School of Biotechnology, myself, Dr. Archana Tiwari, Dr. Mahavir Yadav, Dr. Manoj Pandey, and Dr. Momita Das. Along with these two faculties are also there. That is Dr. Suresh Kumar Jatwa and Dr. Mrityunjay Singh. One more faculty is there. That is Mrs. Priyanka Mishra. So we have the qualified faculties with their specific specializations. Myself mainly working on the molecular medicine and environmental biotechnology, that is on material sciences. Dr. Suresh Kumar Jatwa is working on, he is having this expertise in genomics and genetic engineering aspect. Dr. Mrityunjay Singh is specialized in biochemistry. Then Dr. Madam Priyanka Mishra is having the specialization in microbiology and downstream processing. Dr. Mahavir Yadav is mainly purely working on various aspects of environmental biotechnology. Associated faculties from outside RGPV, that is from Indian Institute of Sciences, Education and Research, ICER, National University of Law, that is NUL, National Institute of High Security Animal Diseases, NIHSCD, and Dr. Reddy's Lab, Hyderabad, Indian Institute of Forest Management, IIFM. Whenever we have a need, special lectures of the experts from IITs, ISCs, and other national institutions are organizing frequently to just give the actual flavor where which type of researches are going on, which is very useful for the students of School of Biotechnology. Students of biotechnology of both the courses, MTech Biotechnology and PGCMB, they are visiting frequently to various institutions such as Indian Institute of Sciences, Education and Research, Bhopal, National Institute of High Security Animal Diseases, Bhopal. This is the Asia's #1 institute related with the exotic diseases, that is viral infections. EMPRI, that is Applied Materials for Processing Research Lab, which is present in Bhopal. Bhopal Memorial Hospital and Research Center, this is the ICMR Institute, and many more. Likewise, our students are, we are providing the training to our students timely, time to time, on the various aspects of biotechnology, that is in the scientific field. First is scientific and soft skills. We are providing the bioinformatics training also, because whenever they are designing their experiments for their dissertation work or proposing or designing their projects, they are beginning their projects from the in silico analysis to in vitro or in vivo analysis. That's why there is a need of bioinformatics training also, and along with this, biosafety and bioentrepreneurship training also. Industrial training, as per the BCIL, Biotechnology Consortium of India Limited, every year 2 students are usually selecting from our department for a training of 6 months. Research, consultancy and extension of the services, that is current research interest of the School of Biotechnology. The School of Biotechnology is mainly working on 2 major arenas, that is medical biotechnology and environmental biotechnology. Under medical biotechnology, we are focusing on epigenetic aspects, that is Cas9 or other tools we are using, that is acetylation, methylation, and so on. Human immunodeficiency virus, that is development of vaccines. We are predicting the vaccines with the help of in silico approach, that is multivalent vaccines. Type 2 diabetes, that is type 2 diabetic retinopathy, cancer, mainly lung cancer, skin cancer, oral cancer, or gallbladder cancer. Industrial biotechnology, under which we are mainly focusing on the preparation of biopolymers. Then nanobiotechnology also, under environmental biotechnology, bioremediation, biodegradation of petroplastics, biosynthesis of biopolymers. Some glimpses of the research papers which we are having. We are also having the Institutional Biosafety Committee and Institutional Ethical Committee also. Some glimpses of the projects on medical biotechnology, environmental biotechnology, and glimpses of publications either in the form of research paper, review article, international letters to the editor, national letters to the editor, newsletter internationally, nationally, or edited books. School is also having the publication in referred journals of this society. Awards and honors, international award to the faculty, national awards to the faculty, and students has also received the national and state level awards. Other achievements of School of Biotechnology, that is extramural projects, international and national both. Projects completed by the School of Biotechnology, that is the faculties of the School of Biotechnology who have completed their international, national on various aspects of medical biotechnology, environmental biotechnology, ongoing projects, and the projects which have submitted to various national and international along with the state agencies. School of Biotechnology is also having a very wide collaborations globally. National Institute of Health, United States of America, Cinevest of Mexico, Indian Institute of Sciences, Bangalore, Center for Cellular and Molecular Biology, Hyderabad, Indian Institute of Technology such as that is Madras, in Delhi, Banaras, Kanpur, Roorkee, Mumbai, Kharagpur, and so on. Banaras Hindu University, National Environment Engineering Research Institute, that is NEERI, Nagpur. And memorandum of understanding has already been done between National Institute of Malarial Research, Jabalpur, and Indian Institute of Soil Sciences, Bhopal. Innovations and best practices, that is the technology transfer and patents granted. We have the patent granted for European patent, US patent, and Indian patent also for the novel clot specific streptokinase proteins possessing altered plasminogen activation characteristics and process for the preparation of said proteins. Patents submitted. 5 patents have already been applied. For Indian, 5 patents have been submitted for the development of subunit RDNA vaccines against Clostridium perfringens, which causes a fatal disease in sheep. Technology transfer, that is novel clot buster for the thrombolytic therapy, and technology tie-up between CSIR India and Nostrum USA for ENET $5 million. Novel strain detected, that is Pseudomonas citronalis for petroleum plastic degradation. Infrastructure facilities, we have the laboratory space, digital classrooms, library, internet and Wi-Fi facilities. That is library, departmental, along with central and digital library also. Glimpses of the departmental library. Digital library is having the e-resources, e-books, e-journals. And student support and progression, that is the alumni placement in educational and research institutions, companies as well. Some students are there in University of Readings, UK, University of Queensland, Australia, University of Putra, Malaysia, Selangor, Malaysia, Jazz University, Saudi Arabia, Tabuk University, Kingdom of Saudi Arabia, Center for Cellular and Molecular Biology, Hyderabad, National Center for Cell Sciences, Pune, Indian Institute of Technologies, that is in Madras, Kanpur, Guwahati, Kharagpur, and so on, Jawaharlal Nehru University, New Delhi, and many more. In companies, Pyramid Life Sciences, Mumbai, Laurus Labs, Hyderabad, Workhat, Aurangabad, IPCA Laboratories, Biocon, Bangalore, Millipore, Bangalore, Dr. Reddy's, Hyderabad, Era Life Sciences, Biozine, Bangalore, Biotech Labs Private Limited, Cactus Global, etc., etc. Events organized, n number of events till date. Some representative ones are AIDS Day, that is Cellular and Molecular Biology, First National Conference on Cellular and Molecular Biology, debate competition, lecture series, that is panel discussion, alumni meet, bioconference, and so on. Bioconference we are going to organize very soon. Some glimpses of these events which the school has already been held. First National Conference on Cellular and Molecular Medicine, AIDS Day, lecture series, that is international lecture series. These are our Mexican partners for the Mexican project, which they visited and worked at School of Biotechnology. Debate competition. Hence, the main objective of the School of Biotechnology is being developed as Center for Potential Excellence in Biotechnology. Thank you so much. I think up now you have already submitted your feedback forms. Dr. Mrityunjay,
Yes, ma'am.
kindly tell me
Many candidates have
feedback forms
submitted.
submitted their feedback forms.
Yes,
Now
ma'am.
we will proceed towards the concluding session.
Yes, ma'am.
Dear participants,
Yes, ma'am.
Yes, ma'am.
we all are the panelists of this first workshop, that is on how to start the lab work under aseptic conditions. We are very humbly putting some statements Welcome the challenges, look for the opportunities in every situation to learn and grow in wisdom. We hope you have enjoyed and enlightened you with all the sessions of this workshop, that is how to start the lab work under aseptic condition. And this, we are thinking these are very useful for your future work also. For these kind words, nowadays we are just, the world is just struggling for the coronavirus. I just want to highlight some important features of the coronavirus. There is a difference between the coronavirus and the COVID-19. Novel coronavirus is the name of the virus, and COVID-19 is the disease caused by this virus. Suppose any person is positive with the coronavirus, it doesn't mean that he or she is suffering from the COVID-19. Kindly focus on this. If anybody is coronavirus positive, but it is not always, it is he or she is suffering from COVID-19. First, the infection is caused by the virus. If it is cured timely and it is not entering in the advanced or the dangerous stage, then it is not at all causing the COVID-19 disease. So, for our protection, we are using hand sanitizers, but it is very, very dangerous. Recent studies clearly indicates that sanitizers causes skin cancer. So please do not use too much of hand sanitizers. Instead of that, use hand wash. Frequently wash your hands as suggested 20 seconds. If you want to sterile your hands, kindly first wear the gloves. Everybody is mainly focusing on face mask. Nobody is very much focusing on hand gloves or face shield or goggles. These are the four important things which are equally important. That is face mask, gloves, face shield, and goggles. Goggles are protecting your eyes because infection can be caused through eyes also. As the infection is caused through your nasal chamber, as your infection is caused through your hands, hands are equally important. So we have to wear at least three important things. One is face mask, second is hand gloves, third is we have to just wear the face shield, and fourth is goggles. Then only we are fully protected, otherwise not. Kindly mind it. If you want to sterile your hands covered with gloves, as we are steriling in our labs. In the same manner, wear the gloves, sanitize it with the help of sanitizer, not directly to your skin. Otherwise, the chances of skin cancer occurs. With these kind words, we all have to fight and stop coronavirus. Thank you so much for your kind patience and attending all this workshop, this first workshop, and make it a grand success. Thank you, one and all. Thank you. Now we are leaving. I think everybody has submitted their feedback forms so that we can generate your e-certificate. We are requesting you all, if this workshop is very helpful, all the sessions of this workshop are very useful for you, to kindly register for the coming workshops also, whose links are already pasted, if I'm not wrong, in the chat box. May I know whether the links are pasted in the chat box or not?
Yes, ma'am, already pasted.
So, thank you so much, Dr. Mrityunjay. I'm again requesting you, if today's 2 days workshop, that is 1st and 2nd of June, are very useful for you, to kindly register for the coming workshops also. That is on 7th and 8th, 14th and 15th, 21st and 22nd, 28th and 29th. Once again, stay home, stay safe, and enjoy your life with safely. Thank you so much. On behalf of the School of Biotechnology, on behalf of the Rajiv Gandhi Pradyogiki Vishwavidyalaya Bhopal, and on my personal behalf also. Thanks a lot for your kind patience, kind hearing, and kind participation. Thank you so much. So we are ending in this manner. We are ending our first batch, that is first workshop